Well, it's great to be here. John Hennessy mentioned the fact that we've tried very hard to build an interdisciplinary kind of way of thinking at Stanford. And so the version of that I want to talk about today is energy. Energy is absolutely the lifeblood of modern societies. It's woven through the fabric of everything we do. It's also something that we need to have available, both for us at reasonable prices, but for all those people in the world that don't yet have access to modern energy services. It needs to be secure. We don't need to have the kinds of disruptions we had in the 1970s because of oil import problems. And it's also one of the primary ways we humans interact with the planetary systems that sustain us around the planet. So we need to be thinking about how we provide and use energy in a new set of ways. I'm going to argue now that underway is a huge transition in the way we do this. It's not the first time the world has done this. So in the 1800s, we switched from wood to coal, then to oil as automobiles came in, then natural gas, and now some nuclear. And now we are embarking on a renewables transition that really is going to transform the world. So what role should a place like Stanford play in this? John mentioned that this is the kind of problem that is absolutely interdisciplinary. It requires all of us across the whole campus to be thinking about how to do this, everywhere from the basic science all the way through the economics and policy and behavioral side of what we do. So we formed an energy institute at Stanford that's meant to bring people together to work on this. We have a couple of hundred faculty across 24 different departments in the university. We're doing now $67 million of research in the interdisciplinary part and a whole bunch more in the disciplinary side. We have hundreds of energy courses. We do a boot camp for new graduate students. We operate on the theory that it would be good to have the energy community know each other. So each year when the new graduate students arrive, we put up 125 of them in 1 week, meet everybody from energy. I can reveal now that the information transfer particle in a university is a graduate student. When faculty collaborate, it's because there's a student running back and forth between them. So having students who know each other across the whole university is a good way to augment this as well. Our students did very well in 2 big national and international competitions, the solar decathlon, where they built a house. Actually, it was a beautiful, lovely house, but incredibly energy efficient, and it took first place in the affordable category. And our students placed 4th in the solar car competition racing across Australia, competing with much more professional teams, and this was absolutely, completely a student effort. I'm teaching with a couple of colleagues, 60 freshmen in one of the Thinking Matters courses, and the Student Energy Club is the biggest student club on campus. So there is a community of folks working on things together in a way that we hope will be hugely productive for the future. So you say, well, okay, what's the issue? These plots kind of are meant to just convince you that there really is no shortage of energy. There's plenty available. It's all about how we convert it to energy services in a way that we can afford. And also we need to pay some attention to being much more efficient about the way we use energy. And we need to think about the impacts that these things have on things like climate and other environmental impacts. So I'll just give you a couple of quick examples. So the truly abundant resource is the sun. You say, well, okay, fine. We know how to make electrons from the sun. But this needs to be much cheaper. And so one way to do that is to make these things out of plastic materials. But this only works if you have the exquisite ability to control things at nanostructured scales, at very small scales. And if you do that, you can build materials that are both cheap and can do the conversions. And of course, students at Stanford are ones who are good at taking those ideas and going into companies. Now, those solar materials need to be connected to something, and so you want electrodes. But you don't want those electrodes to block the sunlight, so if you can make them transparent, then that creates all kinds of opportunities. And so a group in chemical engineering has done this, and that's also being commercialized. And then if you can make electricity when the sun's shining, you need to think about what are you going to do when the sun's not shining. Sun shines pretty much half the time no matter where you are on the planet, which half depends on the time of the year and where you are. But in any case, there is that nighttime thing. So one way to think about that is batteries. Those of us who trying to think about ways to change the transportation system also are interested in batteries. Batteries are big, heavy, and they cost a lot. So we have a number of groups working on ways to make those better. It turns out this is another place when you have exquisite control over tiny little structures, you can think about replacing the standard carbon electrode in a lithium-ion battery that's in your cell phone or laptop with one that uses silicon, where you can put 4 atoms of lithium where only one would go if it were carbon. This gives you a denser battery, and this group led by Yi Cui and Material Science now has commercialized this in a company called Amprius that's just selling their first products now. So energy research is distributed across the whole campus, as I said, and it goes all the way from the basic science end of things at SLAC and the National Laboratory Accelerator Laboratory there, to lots of technology and engineering science in the School of Engineering and in Earth Sciences, to the behavioral side in an energy efficiency center, to the economics and policy and regulatory and finance side. All of those pieces need to fit together to change the world's energy systems. So we should also be thinking about how we can do this better on our own campus. Did any of you, when you were students, go on a tour of Cardinal Cogen? Anybody? Oh, well, things have changed. So one of the things, we have actually about a 50 megawatt power plant on the campus, but it's nearing the end of its life. And so we've been working on a new system that will basically take the heat that we take out of buildings, push it back into the hot water side so that we can supply the heat we need other places on the campus. And so that's fuel that we don't buy. And over about a 30-year period, it saves hundreds of millions of dollars. It reduces our fuel use by about 35% and reduces our CO2 emissions by about half. And it reduces the water use on campus by almost 20%. So these are big changes that are part of our attempt to not only work on the science and for the rest of the world, but to do a good job of it on campus. So I'll close. There is a transition underway to new energy systems with much better services and greatly reduced impacts, and it's one of the central challenges we have to face in this century. It's underway, but there's a lot more to do, and we need to stick with this over time. There is a huge economic opportunity in doing this. We are going to transform the world in terms of the way the energy businesses work. There's no single simple solution to the challenges, but that creates lots of opportunities, and we need a broad portfolio of research to support all that. And that's the place where Stanford can play a role. So let's get to work. We can do this, but we do have to stick with it. Work on energy efficiency, that's something we can all do. Work on electricity, low carbon electricity generation, lots to do there and lots underway. And build a research capability that will provide the tools that we need to develop in the future. We're kind of in a situation where we need all the tools we have now plus some more we need to invent, and inventing new tools is what we're all about. So this is just exactly the kind of challenge that Stanford students and faculty and research staff should undertake, and that's what we are determined to do. Thank you very much.